Well, so far I'm very happy with my Adcock and Shipley 1A milling machine. Most of the small issues have been sorted out, but there are a couple which remain. One of those is this. And this. Now, the oil leaks are a bit of a problem in that my oil level goes down, and also it's a bit messy, and I have to be a bit careful from running the vertical head at high speed. Since I don't have a manual for the machine, I'm going to have to take this apart by trial and error. And what I'm going to do is actually leave this mounted on the machine, because some of these parts may require purchase to get them off. So while it's mounted here, it's nice and rigid. The other advantage is that if I were to take this off and put it on the bench, it actually doesn't sit flat except on its back, and that may not be convenient. So I think I'll dismantle it as much as I can in this position, and then take off what's left of the body later. Anyway, we'll start with what we've got and we'll see how we get on. So there's a set screw in here. Okay, that moves. Didn't expect that to turn by hand. Okay, I've knocked up this makeshift spanner out of some scraps of wood. It seems to work. Okay, that just seems to be a bearing cap. And I put that back in position because we don't want any dirt getting in that nice bearing at the top there, which looks very expensive. So I think what we're going to do is we're going to rotate the head and have a look underneath, because this is where the oil leak is. So hopefully there's an oil seal that we can get to fairly easily from the other side. So we'll rotate the head. I wonder if this has ever come off before. It looks like there are some jacking screws there, so I might try and pull it off. At the time I thought the flange was tight in the casting, but it wasn't. It was actually tight on the spindle, which is obvious now when you look at the video. Okay, I've decided to do this the proper way. We're using the jacking screws. These are just quarter Whitworth or quarter UNC, and you see that comes off really nicely. Should have done this to start with. I just doubted that I had the right set screws to fit these holes, but I borrowed these from my lathe 4-way tool post. Yeah, it's coming off nicely. What I'm hoping is that the oil seal is pressed into this and we don't have to disturb the bearings or anything else. We can just replace this oil seal in this rim here. We'll see. Just with a bit of packing there to give the screws a bit of extra length. Oh, this is nearly off anyway, look. Nearly there. Yep, I think that's it. Great. No, that's not the oil seal, that's just a cover. Close fitting cover. Looks like the oil seal's behind this, and this is going to have to come out. So it looks to me like this is going to have to drop out, which is a much bigger job. Then we'll keep dismantling until we can find this oil seal. I think the next stage is to have a look here more closely. There are 4 cap screws here, and this is a machine face. So although there's paint covering up these joints here, it looks very much to me as if this is bolted on the face here. So if I clean out these joints here, slacken off these cap screws, I'm going to try and remove that cover and get a better look inside. Now, I think we're going to definitely have to get into the top here. So if I remove the cover, have a closer look. Zoom in a little perhaps. You can see here this is a nut, and it's a locking nut with a clamping action, just as I found on the end of the milling machine when I replaced that bearing. So I think that one of these will be a cap screw, probably this one here, which clamps the split nuts so that basically it locks the nut. So I need to undo that, and these two holes here are for driving the nut, unscrewing it. I'm going to have to remove that, and I think what's going to happen is that shaft's going to go out the bottom. You can just see here the large upper bearing. So I'm keeping the cover on for the moment, just to stop dirt from getting in there, but we're going to have to come back to this and release that, I'm quite sure. So we'll go around the other side and get that cover off. I'll probably do some of that offline, and then when we get near to opening it, I'll turn the camera on again. So I've cut into the paint around here. It's clear that this has been painted after the cover's been put on. Remove the set screws and just gently tapped it. So there are no dowel pins in there, so it just slides. And I'm just carefully brushing away the dirt. I don't want that to go inside. So hopefully we can get this off soon. Yeah, it's coming. Okay, it's an aluminium cover. Now we can see the bevel gears. Okay, the first surprise for me was I thought the bevel gear would be at the bottom rather than the top. Okay, this requires a bit more investigation. I set to cleaning inside here. It was really messy. There was a mixture of old oil and grease, so it was all mixed up together. I haven't been able to clean perfectly, but all I can see from this side and sort of reach around the back there. Now, I was expecting, as I mentioned earlier, that this gear would be on the bottom, but it's on the top for a very good reason, and that is that this shaft here is not actually a shaft, it's a tube, and the shaft runs through the middle, and this tube is stationary, so it's actually part of the body in effect. So, I mean, it's a separate assembly, but it's located in there with this set screw. And what actually happens is the oil sits about this level, and this gear picks it up, transfers it to here, and some of it goes over the back and lubricates the journal. And this collar here, this sort of tapered collar, rotates with it's a separate piece, but it rotates with the gear, and the idea is that it flings the oil off and stops the oil from going up inside into the tube. So effectively you have two separate systems. You have the oil bath for the gears and the journal, and then you have the lubrication of the bearings at the top and the bottom through these grease nipples. Now, there is obviously some communication between the two, because some of the grease was around the inside here in this chamber, and it kind of spilled over from the bearings. But while I've come this far and I've cleaned everything up, there's no oil in there, I thought that it would be worth just checking that this seal is working properly. And to do that, I've got to get the shaft out. And what I've discovered is it's a really good fit in the bearings. So normally, this is the bearing retainer, and that surface pushes down on the bearing, and this nut here holds the inner journal. So what I've done is I've unscrewed this, so that it touches the top of this cover, and then screwing this cover in, what you're effectively doing is pressing on the end of the shaft. And if I tighten that up again, you'll see this ring lifts. There, now you can see it definitely is lifted. So then I'm using these 4 circuit head cap screws to basically pull this ring down, and in so doing the cover, and the cover's pressing on the nut and the nut's pushing the shaft down. So I've worked away at that, and I've got this to move so far around about 5/8 of an inch. So it's definitely coming out, but it's pretty hard going. So I'll persevere with that. I'll see how much more I can do with this. I might need to put something else, some other packing in there to get enough movement. This is painstakingly slow. I'm just measuring the progress with my depth gauge. It's moving, but it's 10th thou at a time. Well, I really should have separated these 2 castings earlier. It wasn't as difficult as I thought it might be. They came apart quite easily. Interestingly, these are hand scraped areas here. I was quite surprised to see that. These are the bolts which clamp the 2 parts together with a circular T-slot. And once I got it apart, actually removal of the spindle was much easier. So I recommend an appropriate stage separating these 2 castings. Once I got this casting separate from the other casting, disassembly was much easier. And I think that was because this bevel gear, or the other bevel gear that mates with this one in this position, was out of the way. And I think what was happening was that as I was pushing the shaft through, the bevel gear was kind of twisting and it was sort of locking it up. Anyway, that's lesson number 1. That is, separate these two components and deal with them separately. I think I was right to leave it on the machine for the heavy stuff, but when it came to final disassembly, it needed to be separate. This keys onto the shaft here, like that. This oil flinger ring, which sits inside the bevel, just as the bevel has a keyway in it, so this has, except it seems to have 2 keyways now. I was really surprised when I saw that, and then I realized straight away what had happened. The ring had slipped on the shaft. In fact, it had moved in front of the keyway, rotated, and when I disassembled it, I basically broached another hole, another slot in this ring. That's why it was so difficult to get apart. So I'm going to have to do something with that. I've got the ring now set up in the 4-jaw chuck, and I'm just clocking it up to make sure it's running concentrically and also in this way. And what I'm going to do then is touch up this bore, and then we'll take it out, put a dummy arbor in to the same diameter, face it, and then do the other side, and that way we can make sure it's parallel, because that's what really matters. So I'm just going to set that up. So I'm just skimming up the critical face now, and then after that the bore, because the burr was thrown up there, and then also the internal diameter of the other surface, just to make sure everything fits squarely. And now I'm making the stub mandrel to support the work so I can turn the other side. It's not as tight on there as I'd hoped. Anyway, what I'll do is I've just cleaned up the edge there, and I'll just put a little bit of Loctite in there just to hold it, and I think that will be sufficient just to just to turn this face in a very, very light cut. I'll let that go in. I can feel it's nice and flat on there, so we'll leave that, come back after a cup of tea and then skim that face. I was careful not to take too much off the thickness because that would affect the geometry of the bevel gears. So just a tidy up really, and then finally a chamfer. So I just managed to tap that off. The glue wasn't difficult to break. It's just cleaned up the inside there, and I've deburred these corners. So we'll check the parallelism. So that's 0.1135, just over 0.113, about 0.113 and a quarter, 0.113 and a bit, 0.113, 0.113, 0.113 and a half. I reckon that's about within half a thou of parallelism. I think that's fine. So that's ready. We redeemed that. I'm pleased about that. That saved some work. So I started to produce a detailed drawing of the whole assembly, and as I was doing that, I realized that the mesh of the two bevel gears is crucial, and I have some doubts as to whether they're currently correct. So I've been looking into how to measure a bevel gear and how to lay it out so that the two cone angles come together and the mesh is correct. And it's a little bit complicated, but I think I've made some progress on that. But it's called me to come back and check my measurements. So I've got a list of critical measurements I need to double check, and then go through, check those measurements, amend my drawing, and just see how the mesh looks. Now, one of the other indicators I have that the mesh might not be correct is this wear pattern, which is on the outside of this gear, but curiously not on the outside of the other. Now that, together with some marks here, for example, it indicates to me that this has been taken apart, and I wonder if it's been put back slightly differently. So those various factors have caused me to question whether I need to look at the mesh and how the gears come together and the spacings. So I'm going through this now, taking some measurements, and I'll put this back on the drawing, and you can have a look at the issues that I've identified. One of the critical dimensions is from the toe of the bevel to the mating face. That will determine the mesh. Similarly for the other bevel gear to the rear face where it's located, a flange width, one of the spacers on the lower end, and the flange which holds the large bearing in place, the width of the bearing itself, and then the spacer. These are all critical dimensions. Then the double checking the thickness of the oil flinger ring and the position of the bores relative to the edge of the casting. I don't have a large enough mic, so I'm having to use this method to measure that hole diameter. All these dimensions were then transferred to the CAD drawing. So the whole purpose of this exercise is to determine the correct meshing of these two gears, and the two variables basically are, assuming everything is square, is this distance can be varied, so it brings the meshing closer in this direction, and this distance, which will be the vertical, in the vertical direction, can also be adjusted. And my suspicion is that in this vertical direction there is a little bit of malalignment. So I'll transfer all these carefully obtained dimensions to my CAD drawing, update them, correct them, and just check that the mesh is correct, or approximately correct. Well, I feel like I've made quite good progress in this first video. I've certainly learnt a few things, particularly about the bevel gears and about the way that this is all designed and put together. And doing the CAD drawings is really helpful for me. I'm going to continue working on those with these revised dimensions, and hopefully I can get the mesh right. I would like to get the spacing correct and assemble it without trial and error, but we'll see if that's possible. In the meantime, I've also got the correct shade of paint for the head. This is Adcock and Shipley Bridgeport Cement Grey. So I've got that. I've got the lubricants ready. I've got a plan in place for solving one of the oil leaks, which I'll share next video. In the meantime, I'm going to continue working on the CAD drawing and share that with you next video. Thanks for joining me. I hope you'll join me again next time.